By the summer of 1941, the world stood on the brink of complete transformation. In Europe, Hitler's forces had unleashed Operation Barbarossa, advancing hundreds of miles into Soviet territory in what appeared to be an unstoppable tide of mechanized warfare. The sight of German armored divisions, tightly coordinated, swift, and lethal, left military planners everywhere searching for the secret behind this devastating efficiency. Many believed it lay purely in tank design or tactics, but within the U.S. Army Signal Corps, a different understanding was taking root. To American engineers and officers, the true weapon behind Blitzkrieg was not just the tank, it was communication. The ability of German panzers to move in unison, strike swiftly, and adapt mid-battle was made possible through wireless coordination. Yet, by 1941, the United States had the opportunity to leap ahead technologically. In a quiet yet decisive meeting on July 22, 1941, the Signal Corps standardized a new generation of mobile radios, the SCR-508, SCR-528, and SCR-538. These would replace outdated AM-based systems and bring into military service a revolutionary new concept, frequency modulation. The choice was bold and forward-looking. Frequency modulation, or FM, had been developed only a few years earlier by Major Edwin Howard Armstrong, one of the most influential inventors in radio history. FM offered a clear and stable signal, resistant to static and electrical interference, the same interference that plagued tank radios surrounded by roaring engines, magnetos, and metal hulls. The Signal Corps realized that adopting FM meant rewriting how entire divisions would communicate, move, and fight. To turn theory into battlefield reality, the Army turned to industry. In Chicago, the Galvin Manufacturing Company, a modest but ambitious firm soon to be renamed Motorola, took on the challenge. The Army assigned two brilliant engineers to the project, Daniel E. Noble, a professor and radio innovator, and Henry Magnuski, a Polish émigré and expert in radio transmission. Both men were tasked with an extraordinary problem: design a battlefield FM transceiver that could survive dust, vibration, heat, and shell fire, yet remain reliable enough for tactical command. Over months of relentless testing and redesign, Noble and Magnuski produced what would become the BC-604 transmitter and BC-603 receiver, the core components of the SCR-508 system. The device was rugged, weighing around 181 pounds, with a sealed chassis to protect against the North African dust and a power output of roughly 25 watts. Unlike the fragile, hand-tuned German sets that relied on vacuum tubes susceptible to vibration, the SCR-508 featured crystal-controlled frequency stability, maintaining channel accuracy within an astonishing 0.01% even under heavy motion. This precision and clarity were revolutionary. For the first time, armored units could maintain clear, stable voice communication across multiple platoons, even while maneuvering through battle. Gone was the background hiss of AM interference. Gone were the lost signals and distorted voices. The U.S. Signal Corps had created a tool that could link every tank commander, every platoon leader, and every supporting vehicle into a single coherent network. More than a new radio, the SCR-508 was the material embodiment of a new philosophy of command. In earlier wars, communication flowed rigidly from the top down. Orders were relayed by runners, hand signals, or flag semaphores. The introduction of FM radio allowed communication to become horizontal, instantaneous, and adaptive. In combat, this meant that if a platoon leader's tank was destroyed, another could assume command seamlessly without breaking formation. Information now moved as fluidly as the tanks themselves. As America entered World War II after December 7, 1941, this networked philosophy was embedded in the DNA of its mechanized forces. The Armored Force School at Fort Knox, Kentucky, trained tank crews not only in gunnery and tactics, but in radio discipline, how to speak with brevity, clarity, and coded efficiency. Officers drilled with maps in one hand and microphones in the other, rehearsing the choreography of voice command warfare. Meanwhile, across the Atlantic, German engineers had reached a technological plateau. Their standard tank radio, the FUG-5, was reliable but outdated, built around AM transmission principles from the 1930s. Its 10-watt output, limited frequency stability, and manual tuning made it prone to static and interference, particularly in armored formations where electrical noise was extreme. Moreover, most tanks in a unit were equipped only with receivers, not transceivers, meaning that only commanders could transmit orders. Subordinate crews could listen but not reply. Coordination depended on a single voice, an advantage that turned to vulnerability once that voice was silenced. In contrast, American doctrine emphasized redundancy. Every tank had both sending and receiving capability. Every vehicle could be a node of information. The decision to mass-produce these radios, taken quietly in 1941, would soon prove to be one of the most consequential technological gambles of the war. By early 1942, production lines in Chicago, New Jersey, and Pennsylvania were humming with activity. Motorola alone produced over 50,000 SCR-508 units within a year. Testing at Fort Knox confirmed their endurance under extremes of heat, moisture, and mechanical shock. When America's armored divisions prepared for deployment to North Africa, their tanks carried not just armor and ammunition, but the most advanced battlefield communications technology on Earth. As the first convoys left U.S. ports in October 1942, the Invisible Revolution was already underway. On November 8, 1942, the still unproven might of the U.S. Army landed on the shores of French North Africa in a campaign codenamed Operation Torch. It was America's first major offensive of the war, designed to relieve pressure on the Soviets and open a new front against the Axis. Nearly 100,000 troops came ashore at three main points: Casablanca in Morocco, Oran, and Algiers in Algeria. Among them were the men of the 1st and 2nd Armored Divisions, bringing with them the newly equipped M4 Sherman and M3 Lee tanks, each fitted with the SCR-508. The landing was chaotic, as most amphibious invasions are. Communications were critical, and it was here that the FM sets first proved their worth. While French coastal batteries fired sporadically and landing craft scattered, armored units maintained contact through the clear, uninterrupted channels of their new radios. Officers could redirect columns in real time, coordinating with naval gunfire and air support in a way that previous AM systems could never have allowed. Once ashore, the Shermans began pushing eastward toward Tunisia, where the veteran Afrika Korps awaited. Led by Field Marshal Erwin Rommel, the Germans had spent 2 years mastering desert warfare. Their supply lines were thin, but their experience was unmatched. Rommel's panzers had previously overrun British forces using superior mobility and coordination, an illusion sustained by effective, though limited, AM radio command. But by late 1942, the technological balance was shifting. German armored formations relied primarily on the FUG-5 transceiver, operating in the 27 to 33 MHz range. Its transmission range rarely exceeded 2 kilometers under battle conditions, and its amplitude-modulated signal was highly susceptible to the electrical whine of tank engines. To minimize cost and conserve materials, most tanks carried only receivers, leaving them mute on the airwaves. This structure worked in offensives led by veteran commanders, but as casualties rose and replacements filled the ranks, coordination began to fracture. When U.S. and British forces met the Afrika Korps in the early skirmishes of December 1942, German officers noticed something unsettling. The Americans seemed to react instantly. Reports filtered back to German headquarters describing enemy tanks that regrouped with uncanny speed, adjusted their movements as if guided by a single intelligence, and maintained formation even after losing lead vehicles. Unbeknownst to the Germans, this agility was the product of FM communication. Inside the American tanks, every crewman could hear the same voice, clear, sharp, and free of static. Platoon leaders could issue real-time adjustments, and coordination with supporting artillery or air cover became second nature. In a post-war report, Colonel Robert I. Stack, commander of a tank regiment in North Africa, remarked that our radios made the difference between confusion and coordination. We could fight as a unit even when scattered over miles. The contrast was stark. German after-action reports from the same engagements often described radio silence after initial contact as damaged antennas, electrical noise, or jamming rendered the FUG-5 ineffective. Command tanks that attempted to maintain communication found themselves overwhelmed by simultaneous messages, as the AM system lacked channel discipline and frequency separation. Though the Americans would suffer their share of defeats in the coming months, most notably at Kasserine Pass, the seeds of a new kind of warfare had been planted. The U.S. Army, through its investment in communication, had begun transforming from an industrial age force into an information age one. Every engagement, every transmission, every field repair of an SCR 508 reinforced the lesson that information flow was combat power. As the North African campaign intensified, the Germans began to recognize the problem. In a memorandum dated March 1943, a signal officer of the Africa Corps lamented that enemy communication between units is constant and clear. Their coordination in battle cannot be explained by visual signals alone. Yet by then, the technological gap was too wide to close. Germany lacked the industrial capacity to redesign and mass-produce new FM-based radios under wartime constraints. Meanwhile, in American factories, the flow of innovation continued. The lessons learned from Torch were fed directly into new designs. The SCR 528 for half-tracks, the SCR 538 for light tanks, and improved versions capable of linking ground units to air support. Engineers introduced standardized frequency channels for different echelons of command, effectively laying the foundation for what modern militaries would later call battlefield network architecture. The arrival of 1943 would bring the system's ultimate test at Kasserine Pass, where U.S. forces faced the full fury of Rommel's counteroffensive. Despite tactical blunders and painful losses, the battle revealed an unshakable truth. In modern warfare, the side that communicates fastest and clearest shapes the outcome. From a laboratory decision in 1941 to the beaches of North Africa in 1942, the evolution of the SCR 508 was more than a story of engineering. It was the opening act in the global struggle to command the invisible battlefield of the airwaves. As American troops established their foothold in North Africa following Operation Torch, the optimism of initial landings gave way to the realities of modern war. The first encounters with the battle-hardened Africa Corps exposed not only weaknesses in training and tactics, but also deep divisions within U.S. Army leadership over how armored forces should fight. At the center of this debate was the question of command and control, the very purpose for which the new FM radio systems had been introduced. The American Armored Force, created in July 1940 and headquartered at Fort Knox, had been the brainchild of visionary officers like Brigadier General Adna R. Chaffee Jr. and Major General Jacob L. Devers. They imagined tanks as independent striking arms capable of rapid maneuver, much like the German Panzer divisions that had overrun France. But as the war expanded, conservative voices within the War Department and the infantry branch resisted this notion, insisting that tanks serve as infantry support weapons, not autonomous formations. This internal tension produced a hybrid doctrine, one that often left U.S. tankers unsure whether they were to exploit breakthroughs or grind forward in close support of foot soldiers. When the first armored divisions landed in North Africa, they carried both this doctrinal confusion and a new technological power. The SCR 508 FM radio had given them the ability to communicate instantaneously across units, but leadership doctrine had not yet caught up to its potential. Tactical reports from late 1942 described platoon commanders who used their radios primarily for receiving orders rather than coordinating maneuvers. Others misused the equipment, overloading channels with chatter and unverified information. At the top, the newly appointed Lieutenant General Dwight D. Eisenhower, commanding Allied Forces Headquarters, AFHQ, faced the monumental task of uniting an army that had never before fought on this scale. Eisenhower's Chief of Staff, Major General Walter Bedell Smith, and his subordinate field commanders, including General Lloyd Fredendall of II Corps, held contrasting views on how to manage communication between ground echelons. Fredendall, an artilleryman by background, preferred rigid command hierarchies, often issuing orders through intermediaries from miles behind the front. His subordinates, including Major General Orlando Ward of the 1st Armored Division, complained that this system neutralized the advantage of FM communications, which were designed for fluid, decentralized control. By early 1943, the debate came to a head. The defeat at Fade Pass and the subsequent crisis at Kasserine Pass revealed that the American Army's problem was not technological. It was organizational. Tanks with perfect radios were rendered ineffective by commanders who refused to trust subordinates to act on their own initiative. In post-battle analyses, communications officers repeatedly noted that units with the best internal discipline in radio use performed most effectively. Platoons that kept their networks open for brief, precise commands moved cohesively under fire, while others degenerated into confusion as channels clogged with uncoordinated messages. At Two Corps headquarters, Eisenhower's liaison officers transmitted their frustrations. "We have the equipment to command a mobile war," one wrote, "but not yet the habit of mind to fight one." The lesson would not go unheeded. Eisenhower's command restructured its armored doctrine, emphasizing flexibility, delegation, and real-time command empowered by radio communication. The FM sets had proven their worth. Now leadership had to learn how to wield them. The turning point in the American approach to command came in the wake of the Kasserine Pass defeat in February 1943. The battle, fought in the rugged hills of western Tunisia, was the first large-scale confrontation between U.S. and German forces. The result was a sobering humiliation. Under coordinated German attacks led by General Hans-Jürgen von Arnim and Erwin Rommel, Two Corps was forced into a disorganized retreat. More than 6,000 Americans were killed, wounded, or captured. Yet among the wreckage lay an equally significant failure: the breakdown of leadership communication. Reports from the battlefield described units operating in isolation, orders delayed or misunderstood, and commanders unable to adapt to rapidly changing situations. While the technology existed to prevent such chaos, it had been neutralized by indecision and mismanagement. Eisenhower recognized that the problem was not in the radios, but in the people using them. Into this atmosphere of urgency stepped Lieutenant General George S. Patton, whom Eisenhower appointed to command Two Corps on March 6, 1943. Patton was already known for his ferocious energy and belief in speed, coordination, and personal control. Where Fredendall had built his headquarters in a distant cave complex, Patton positioned himself near the front lines, often monitoring radio traffic directly. He understood that the SCR 508 gave him an unmatched tool, the ability to command a dispersed force as if he were physically present at every engagement. Patton's first directive to his officers was uncompromising: keep the air clear. Speak short. Speak fast. Every man must hear what he needs to know, and nothing more. He instituted standardized radio procedures, mandating brevity codes, authentication protocols, and hierarchical priority channels. To his staff, he explained that discipline on the air was as vital as discipline on the field. "The enemy can move fast because he knows what his neighbor is doing," Patton told his commanders during a briefing in Gafsa. "We will move faster because we will always be talking." The transformation was immediate. Under Patton's leadership, communication became the backbone of maneuver warfare. Platoons no longer waited for written orders. Instead, they adjusted positions based on live situational updates transmitted over FM networks. Coordination between tanks, artillery, and aircraft reached unprecedented levels. For the first time, American ground forces began to exploit the full potential of frequency modulation as an operational doctrine rather than a technical novelty. By April 1943, the effects were visible across the Tunisian front. Patton's reorganized Two Corps performed with remarkable cohesion during the Gafsa, El Getter operations, repelling German counterattacks and demonstrating a newfound unity of action. Field reports credited not only Patton's leadership, but the decisive advantage of reliable radio communication between command and subordinate echelons. The transformation impressed even the British. Observers from Montgomery's Eighth Army, accustomed to cautious, methodical advances, noted the speed and fluidity of American maneuvers. British liaison officers were astonished that entire armored columns could change direction and concentration within minutes of receiving a radio order. What had once been a liability at Kasserine was now a strength. Eisenhower, observing from Allied headquarters in Algiers, took note. His post-campaign evaluations emphasized that the decisive element in the rehabilitation of Two Corps was the institution of clear, continuous, and disciplined communication. The American Army had not merely adopted new technology, it had redefined its command culture to suit it. The lessons from Tunisia would shape all future Allied campaigns. As planning began for Operation Husky, the invasion of Sicily, and later for Operation Overlord, the invasion of Normandy, the role of FM communication became institutionalized. Every armored battalion would deploy with designated radio control officers, frequency allocation tables, and standardized operating codes. The War of Voices had matured into the War of Movement. By mid-1943, Patton's once chaotic corps had become a model for modern command. The coordination between armor, infantry, and air support that had eluded the Allies in North Africa would now define their victories across Europe. What began as a laboratory experiment in 1941 had evolved into a doctrine of dominance, one that fused human leadership and machine precision into a single, seamless instrument of war. The transformation of American armored communication was not born solely in the field, but in the factories and laboratories of the United States. Between 1942 and 1944, the marriage of engineering ingenuity and industrial might created the logistical foundation that made universal FM deployment possible. It began with the U.S. Army Signal Corps' decision to standardize radio sets across all medium tanks, ensuring compatibility from platoon level to division command. The chosen series, the SCR 508, SCR 528, and SCR 538, became the nerve system of the American armored arm. The engineering roots of this revolution lay within the Galvin Manufacturing Corporation of Chicago, the company that would later become Motorola. Under the leadership of Daniel E. Noble, a visionary engineer who had previously worked on FM radio applications at the University of Connecticut, and Henry Magnuski, an expert in high-frequency radio circuits, Galvin's engineers undertook a monumental challenge, adapting Edwin Armstrong's FM principles to the harsh, vibration-filled, electrically noisy environment of armored vehicles. The result was a radio set both durable and revolutionary. Each SCR 508 set weighed approximately 181 pounds and contained over 2,700 precision components, including crystal-controlled oscillators that maintained exact frequency alignment despite heat, motion, and shock. The transmitter, Model BC 604, delivered 25 watts of power, far surpassing the 10-watt German FUG-5. Its twin BC 603 receivers allowed tank commanders to monitor two channels simultaneously, one for the platoon net and one for company command. This dual listening capability, unavailable to any Axis tank system, turned every Sherman into a command node capable of receiving and relaying orders with unmatched flexibility. In late 1942, the War Department launched an accelerated production program that mirrored the urgency of the Manhattan Project in its coordination. Motorola, Western Electric, and RCA cooperated under the Signal Corps to mass-produce FM radios on an unprecedented scale. By the end of 1943, American factories had delivered over 11,000 sets, with total wartime production exceeding 50,000 units, enough to equip every Sherman tank, command half-track, and armored car in the U.S. Army inventory. Production statistics tell the story of a nation at the peak of its industrial potential. In 1942, just 3,800 SCR 508 family radios rolled off the line. By 1944, annual output had surpassed 24,000 units. The United States achieved what no other belligerent managed: complete radio saturation across an entire armored force. German factories, struggling under Allied bombing and material shortages, could produce only about 6,000 FUG-5 transceivers in the same period, barely enough to supply 1 in 5 tanks with two-way communication. The American system's superiority was not limited to raw production. The technological philosophy behind it represented a new concept in warfare: the creation of a networked battlespace. Unlike their German counterparts, who relied on hierarchical orders transmitted through a handful of command vehicles, the Americans built a communication web in which every tank, artillery observer, and reconnaissance car formed a living circuit. Orders could flow laterally between units as easily as vertically through ranks. In essence, the U.S. Army had created the world's first real-time digital architecture, analog in form, but networked in function. The logistical success of radio deployment also owed much to American standardization. Each armored unit carried interchangeable radio components, spare crystals, and maintenance kits. Training manuals, such as the War Department's TM-11 to 600, 1943, outlined exact procedures for tuning, frequency allocation, and troubleshooting. Signal maintenance companies were embedded directly into armored divisions to ensure continuous operation. When tanks rolled off the assembly lines in Detroit Arsenal, their radios were already aligned and tested, ready to join the battlefield network without further modification. By mid-1944, this invisible web of electromagnetic connectivity stretched from North Africa to France, from Sicily to the Rhine. It was a silent force multiplier, one that made the difference between isolated combat and coordinated warfare. As the Allied invasion of Europe loomed, this network was about to prove its worth in the largest amphibious operation in history. When the first waves of M4 Sherman tanks rolled ashore on June 6, 1944, the SCR 508 radios inside them maintained contact not only with other tanks, but also with naval gunfire support and field artillery units inland. This integration of land and sea communications represented the maturation of a concept first imagined by engineers 3 years earlier. That communication, not armor thickness, would determine success on the modern battlefield. However, the Normandy campaign also exposed the limitations of even the most advanced systems. The dense hedgerows of the Bocage region created visual and radio obstacles that reduced communication range and restricted tank infantry coordination. Infantry radios, primarily SCR 300 backpack units, operated on frequencies between 40 and 48 MHz, incompatible with the tank's 20 to 27.9 MHz band. The consequence was deadly. In numerous engagements near St. Lo, German infantry armed with Panzerfausts ambushed American tanks that were unaware of threats spotted by nearby foot soldiers who lacked a way to warn them. The solution was as simple as it was ingenious. Field workshops under the supervision of 1st Army signal officers began attaching E-8 field telephones, the same handsets used in wired infantry communication, to the exteriors of tanks. These telephones were wired directly into the crew intercom systems, allowing infantry to speak with tank crews instantly. By Operation Cobra in late July 1944, this modification had become standard across U.S. armored divisions. The results were immediate and dramatic. Tank infantry coordination improved, ambush casualties fell, and combined arms tactics began functioning with precision. Operation Cobra, launched on July 25, 1944, was the operational debut of fully integrated American radio warfare. Under Major General Edward H. Brooks and the 2nd Armored Division, more than 200 Sherman tanks coordinated through pre-assigned radio networks that spanned multiple divisions. Air liaison officers, artillery batteries, and reconnaissance patrols shared live updates, creating what one observer called an orchestra of steel conducted by invisible waves. German defenders of the Panzerlehr Division, though equipped with superior Panther and Tiger tanks, were overwhelmed by the Americans' ability to maneuver and call fire support in near real time. Within 5 days, the German line collapsed, marking one of the most decisive breakthroughs of the Normandy campaign. As Allied forces advanced toward Germany, the radio network expanded into a continental web. During Operation Market Garden in September 1944, airborne and armored units coordinated across hundreds of miles using standardized communication procedures. Despite the operation's strategic failure, the technical performance of American FM radios remained flawless. In the winter of 1944 to 1945, during the Battle of the Bulge, communication again determined survival. When German forces launched their surprise counteroffensive in the Ardennes on December 16, fog and snow grounded Allied aircraft and severed visual lines. Yet American units, connected by radio, maintained cohesion even when surrounded. Elements of the 101st Airborne Division in Bastogne, cut off by weather and enemy encirclement, continued to relay reports via Armored Division relay stations operating SCR 508 sets mounted on half-tracks. The resilience of this network enabled Allied headquarters to track the situation in real time, directing reinforcements that eventually broke the siege. By March 1945, as Allied forces reached the Rhine River, the efficiency of American communication reached its zenith. During the capture of the Ludendorff Bridge at Remagen, radio reports from 9th Armored Division tanks reached 1st Army headquarters within minutes of discovery, prompting a lightning response that secured one of the few intact crossings into Germany. German units, reliant on field telephones and fragmented radio coverage, failed to coordinate a coherent counterattack. Within hours, American armored and infantry units established an unbreakable bridgehead, an achievement made possible by the rapid flow of radio-transmitted intelligence. By the war's final months, every armored unit in the U.S. Army operated as part of a synchronized communication organism. German commanders, including Heinz Guderian, who had once revolutionized armored warfare through radio coordination, could only watch as their own forces struggled with limited transmission range, interference, and command breakdowns. American FM superiority had rendered the very principles of blitzkrieg obsolete. What began as a technical experiment in 1941 had evolved into a new kind of warfare, network-centric combat. For the first time in history, victory depended less on the individual power of machines and more on the invisible coordination that bound them together. By the spring of 1945, the European theater had reached a state of accelerated collapse. Yet it was not only the physical destruction of German industry or the encirclement of its armies that sealed its fate. It was the systematic paralysis of its communication networks. What had once been the tactical brilliance of Heinz Guderian's Panzertruppen, dependent on rapid orders and decentralized execution, had withered under the relentless pressure of Allied FM coordination. As the U.S. 12th Army Group, commanded by General Omar N. Bradley, advanced through western Germany, the operational tempo of Allied divisions far exceeded the ability of German units to respond. German forces, fragmented by retreat and lacking standardized communication frequencies, frequently found their own units operating on incompatible channels. Field reports from captured officers, such as those from the 352nd Volksgrenadier Division, revealed that many panzer and infantry units could no longer reach higher headquarters except by courier, an impossible task under constant air attack. In contrast, American divisions operated as coherent, self-reinforcing networks. The Third Army, under General George S. Patton, executed some of the fastest maneuvers in modern history, covering over 60 miles in less than 48 hours during its crossing of the Rhine River at Oppenheim on March 22 to 23, 1945. The coordination behind this movement, between engineers constructing pontoon bridges, tank columns securing crossings, and artillery units laying suppressive fire, depended on the flawless interplay of FM radio systems. Every element of the advance, from the platoon to corps level, was orchestrated through continuous communication. One vivid episode recorded in the Signal Corps archives details how Combat Command A of the 4th Armored Division maintained uninterrupted radio contact from the Rhine bridgehead to division headquarters over a span of 42 miles, despite terrain and enemy interference. German defenders, relying on outdated AM sets, attempted to jam the frequencies but failed, as the frequency-modulated signals cut cleanly through static and distortion. Engineers monitoring the transmissions noted with satisfaction that FM's signal-to-noise ratio remained consistent even under heavy electrical interference, precisely the condition in which AM radio failed catastrophically. The cumulative effect of this superiority became visible by April 1945. In the Ruhr Pocket, where over 325,000 German troops were surrounded by the 1st and 9th U.S. armies, FM coordination allowed the Americans to manage an encirclement front of more than 200 miles with near-perfect synchronization. German attempts to break out were thwarted before they began, as reconnaissance aircraft and tank units shared positional updates by radio in real time. It was here that U.S. Signal Corps historians began referring to the American command network as the electronic nervous system of the modern Army. In one internal report dated April 1945, Colonel William R. Blair, Chief of Radio Intelligence, wrote, "We have reached a point where communication has become as decisive as firepower. Command that speaks in seconds will always defeat command that moves by hours." By the time Adolf Hitler committed suicide in Berlin on April 30th, 1945, the Wehrmacht's communication web had disintegrated. American divisions, in contrast, had demonstrated that disciplined structure and technological cohesion could accomplish what raw firepower could not: the sustained execution of strategy across multiple theaters at once. The war had proved, beyond dispute, that the mastery of the electromagnetic spectrum was the true hallmark of 20th century warfare. The end of World War II did not conclude the story of the American radio revolution. It marked its global expansion. The principles born from the SCR-508 program and the U.S. Signal Corps' wartime research became the foundation for post-war communication systems, both military and civilian. Immediately after the war, the United States Army undertook Project Signal Research 1946, aimed at evaluating the wartime FM network's performance and integrating lessons learned into peacetime doctrine. The project confirmed that the average uptime of American radio systems in combat exceeded 92%, compared to 53% for comparable Axis networks. The resulting doctrine, codified in Field Manual 24-5, 1947, established a permanent hierarchy for command communication that would shape every U.S. military operation from Korea to Iraq. In the broader industrial context, the innovations developed for armored FM systems laid the technological groundwork for the rise of Motorola's civilian communication empire. The same engineers who had built the SCR series went on to create the first commercial FM radios for public safety, launching the handy-talkie HT-200 in the 1950s, the direct ancestor of modern police and emergency radios. The signal processing methods refined during the war also contributed to the development of early television and, decades later, to the modulation techniques used in cellular communication. Strategically, the war's communication paradigm shifted global military thinking. The Soviet Union, which had relied heavily on wired communications and courier networks during the war, began reverse engineering captured American equipment. This research led to the creation of the R-105 and R-123 series of Soviet tank radios in the 1950s, which emulated U.S. FM stability and modular design. Today, the invisible lineage of the SCR-508 extends into satellite communication, encrypted tactical networks, and even civilian technologies like Wi-Fi and 4G, each an echo of the discovery that stable, clear, interference-resistant communication could alter the course of history. The victory of 1945 was not only a triumph of armies and machines, but a triumph of signal, logic, and organization, a triumph of thought transmitted at the speed of light. In the words of General Dwight D. Eisenhower, reflecting years later on the coordination of the Allied forces, "Our greatest weapon was unity, and unity was made possible by communication." From the steel hulls of Sherman tanks to the silicon circuits of the modern battlefield, the legacy of America's wartime radio network endures. It is the silent thread that connects the voices of the past to the frequencies of the present, a testament to the idea that in war, as in peace, the power to communicate is the power to prevail.